Today's lesson is on section 5.2, use linear equations in slope-intercept form. It's still very much like the first section, like 5.1, where we're going to be writing equations in slope-intercept form. But now instead we're going to get a little bit different information for this section and have to maybe work a little bit harder in terms of making the equation, figuring out some of the things ourselves. Again, here's slope-intercept form, y equals mx plus b. And so notice in slope-intercept form, there's two key parts to it, the slope and the y-intercept. So as I've have here written in red, and if you're taking notes along with me, I'd want you to write this down. It says we know that we can make an equation as long as we know those two things, the slope of the line and the y-intercept of the line. So we had problems just recently where they said the slope of this line is 10 and the y-intercept is negative 1,250. And I just used some bigger numbers there to exaggerate and just make us realize it doesn't matter what the numbers are, though, as long as we know what those two things are. The slope, if the slope is 10, I'd put y equals 10x, and the y-intercept's negative 1,250. Well, then I write minus 1,250. And so again, whatever those numbers are, that's where they go in the equation, in for m and in for b. I substitute those in, and that's what my equation would be. But in this and then again, in that first section, 5.1, in all the problems, they gave us the y-intercept. Okay, so we knew what that was. We didn't really have to work for it. Some problems, it gave us the graph, or it just gave us that point, like 0, 2, or even it just said, here's the y-intercept, just like this example I made up here is. So, but now, what if they don't give us the y-intercept, that other piece of information? There's ways we can still figure it out. There's a couple ways, but we'll talk about a way we can do it algebraically here today. So looking at an example of what a problem might look like in this section. This problem says write an equation. So just like we've been doing, we're going to write an equation. It's going to look like this. Y equals mx plus b. I just need to figure out what m is and what b is. So it says write an equation for the line that passes through the point 3, negative 2 and has a slope of negative 1. So I know this information, but I don't, if you notice up there, this point that they've given me in this case, this is not the y-intercept. That point is not on the y-axis. It's just a point that has some information for me. I know that the line goes through 3, negative 2. And I know what the slope of the line is, so I kind of know what it looks like, but I don't have the y-intercept itself. So if I was going to pick out, and start doing what we usually do, let's say, okay, I'm going to find m and b. Well, in this case, I do know m, though. I've got negative 1 as a slope, but I don't know what the y-intercept is. How can we find that? I'm going to show you there's two good ways, or two ways that I've kind of seen, and there's a few other kind of intuitive ways you can think out the numbers and figure it out as well. But I'll show you two ways that I think are the best two ways that could work. And one is just with a graph, and the other way we're going to show more is algebraically. So first of all, one thing you could do is you could make a graph, as I've got down here. If I know that this line goes to the point 3, negative 2, let's plot that point and see where this is. Well, from the origin, here's the y-axis, here's the x-axis. I'd go over 3 and down 2. Well, there would be the point 3, negative 2. And then it has a slope of negative 1. Well, I know what that looks like, and I can even think of it as a fraction here for a second, negative 1 over 1. I could think down 1 over 1, down 1 over 1, down 1 over 1 to find more points. Or reverse the directions, left 1, up 1, left 1, up 1, left 1, up 1. And I could find the y-intercept with that, like using a graph. Here's the y-intercept, it'd be 1. So b would equal 1 for this problem. So that's one way I could do it. I could make a graph and I could kind of figure it out. But what if the point I know, is something where it's like 20, 55 or something way away from the y-intercept, where my graph would be I have to change the scales and it would kind of distort it. It'd be tough to find. Or again, maybe I don't want to make a graph every single time. There's a way to find the y-intercept without making a graph. What we can do is take the slope-intercept form that we know. So I'm going to write that down here just as a reminder. But y equals mx plus b. These are all variables that stand for something. And usually, if I know m and b, I can plug them in to this formula. Well, in this case, I know what m is, so I don't know b, though. But I can plug m in. So let's just make one change here. I'll put negative 1 in for m. Then I still have x here, and then I still have b. So I don't know what this is. This is still my biggest unknown that I'm trying to find out right now. Well, this is using the slope. This is m. And what other information I have? This other information is important here. This point. If I think about what a point is, it's an x-coordinate and a y-coordinate. Well, in this in this equation here, I have a spot where I can put x and y in, each of those two variables. So let's try that and see what happens here. I'm going to put 2 in for, negative 2 in for y, because that's the y coordinate. And I'm going to put 3 in for x, because that's the x coordinate. And now the only thing I don't know in this equation is b. And if I ever have an algebra equation where there's only one thing I don't know, I can solve around and figure that out. So now looking at this problem here, oh, negative 1 times 3, I can figure that out. That's just negative 3 plus b. And then now thinking like we usually do when we solve an equation for a variable, we try to get it by itself. This says negative 3, so I'm going to add 3 to both sides. I get 1 over here, I get b, so I guess all by itself I have b now. So b equals 1, which is what we said it was going to equal earlier, shown from the graph. So that's the way I can find the y-intercept algebraically. If they give me enough information, a point here, and the slope, what they've given me is m, and they've given me x and y, well then I have 3 of the things that need to go into this equation. I have the x coordinate, the y coordinate, and I have the slope. So I can plug those things in, and I can find out what b is, and then use that to make my equation just like we've done before. In this case, it'd be y equals negative 1x plus 1. Let's try that same thing with this next example. So example number 2 here, we're gonna write an equation that passes through the point 6, 7. Passes through the point 6, 7, and has a slope of 2. So again, here's my m. And again, also just kind of consider this is an x coordinate and a y coordinate. We'll keep that in mind here as we go through it. Well, again, one way you could do this problem is you could just plot the point 6, 7, and then you could figure out a slope of 2 and maybe kind of work backwards in terms of, on the graph, what your y-intercept would be. So let's see, 6, 7, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Here's the point 6, 7. A slope of 2 would be like up 1 and right 2. Or if I'm going to think backwards here so I can hit the y-axis, I can go down 2, left 1. So I'm just going to kind of repeat that over and over and over here until I hit the y-intercept, or until I hit the y-axis. So here would be my line, and I'm at 1, 2, 3, 4, negative 5. So I'm calculating here from my graph that the y-intercept of this graph would be negative 5. That's what I should get. Okay. Now let's try to do it algebraically. And so again, if I think about slope-intercept form, y equals mx plus b, I'm trying to make an equation like this. Well, the two things that I need are the slope and the y-intercept. I need m, and I need b. Well, again, m I have. I have a slope of 2, so I know that. But I don't know what b is, and I don't have that information. This, again, this 0.67 is not the y-intercept. I can't use that. But what I can do is let's plug in the things that we know right now. I'm going to plug 2 in for m. I'm going to plug 6 in for x, and 7 in for y. So what will this look like? Well, it'll look like 7 equals 2 times 6 plus b. That's me just plugging in the things that I do know from what the information they give me. I plugged in the slope. I know what the slope is. And I do have this x and y coordinates. So I can plug those in for x and y. So now I've got 7 equals 2 times 6 plus b. Well, I can do this part right here. 2 times 6. That just gives me 12. So 7 equals 12 plus b. And then now I'm going to subtract 12 from both sides, trying to get b by itself. And so I'll get negative 5 over here, and this side will be b, so it's b equals negative 5, which is what I found over here from my graph. So again, both these ways are just fine. But if, again, the graphing, depending on the numbers and depending on what you have, it may be kind of tricky to do the graphing part. So the algebraic way will always work. If I'm making this equation, y equals 2x minus 5. Just walking through a couple examples just to make sure we have the idea. So again, let's say this problem says write an equation. So I'm going to make some equation that looks like this. Write an equation, y equals mx plus b, for a line that passes through the point 3,4 and has a slope of 4. Okay. Well, again, they're telling me what m is right away. So if I'm going to pick out m and b, just like we usually do, I've got m already. But b, the y-intercept, I don't have. This 0.34 is not that. Again, I'm going to graph this one just to kind of show 1, 2, 3, up 1, 2, 3, 4. Okay. And so let's say that's my point, and then I have a slope of 4. Again, just for kind of the idea to realize why graphing doesn't always work, or why sometimes it could be a little messy. Let's say the slope wasn't 4, though. Let's say it was something like, -8, okay, or -10. Let's say it was something maybe a little bigger. Well, then if I start making a slope of -10, I'd have to go back 1. I have to go down 10 and over 1 to find a point first of all, and then to reverse the slope to find my y-intercept, I'd have to go left 1 and up 10, which might be somewhere up here, and then left 1 and up 10 again, which might be somewhere up here, and then up here, and again, then I'd have to make a graph that would go up to at least like 30 just to be able to find out what the y-intercept is. So again, just for example, why graphing does work, but here's why we definitely want to learn the algebra way too, because this can help us no matter what the numbers are. But going back to our example here, so let's say it passes through the point 3, 4 and has a slope of 4. I could work this one backwards, so 1, 2, 3, 4 and over 1, but I can go down 4 and left 1, down 4, left 1, down 4, left 1. It looks like my b is -8 for this line if I graph it. Okay. So now let's check and see if we get that same thing, and again, that'll tell us, are we doing it right? So for this one, again, here's slope-intercept form. Y equals mx plus b. I know what m is. And also I know this point, which is an x and a y coordinate that works in the equation. So again, I'm just going to take x and plug it in take 3 and plug it in for x. I'm going to take 4 and plug it in for y. And the slope I also know, which is 4. I'm going to plug that in too. So I'm going to have 4 equals 4 times 3 plus b. Now I'm just going to solve this equation for b. 4 times 3 right here I can do, which is 12. So 4 equals 12 plus b. Subtract 12 from both sides, and I'm going to get b equals -8, which is what we found. My equation should be y equals 4x minus 8. So again, just kind of showing that the graphing way does work, but there could be in the future numbers that make that a little more difficult, where I have to increase my scale or change things around. The algebra will always work as long as I know where to plug things in, and just kind of looking at the problem and realizing what I do have, x, y, and in this case the slope. I'm going to show us one other type of problem that we will see here too, either today and also in the future. Again, let's say we're going to write an equation. I'm going to write an equation in slope-intercept form. That's the way we know how to write them right now. So I want to pick out m and I want to pick out b. Well, in this problem, notice that it just says write an equation of a line that passes through these 2 points. So I don't even have the slope to start right away, and neither of those points is the y-intercept either. So right away I don't have m and I don't have b. I don't have either of those 2 things. So what can I do in a problem like this? Well, remember back to just recently, like the last section, we talked about, though, if I have 2 points on a line, there is something that I can find. I can find the slope of this line. So m I can actually figure out right now. I can just take like 13 minus 3, subtract the y coordinates, and 7 minus 2 and subtract the x coordinates. So 13 minus 3 over 7 minus 2. 13 minus 3 is 10. 7 minus 2 is 5. 10 divided by 5 would give me 2. There, now I've got the slope of this line. So that's good. At least I have m. I still have to find b. Well, how have we just recently found out that we can do that? Okay, I don't have what the y-intercept is, but I am going to make some equation, y equals mx plus b. Well, again, plugging in what we do know now, I know m, so I can plug that in for 2 in for m. Okay, what about x and y? Well, go back to, in this case, we know that this line goes through both of these points. This line goes through the point 2, 3, and it goes through the point 7, 13. Both these are x and y ordered pairs that will work for this equation. So when trying to figure out what to decide, okay, well, which of these points will work, or what could I plug in for x and y in this equation I'm going to use to find b, realize that either one would work. I just got to pick one and go with it. So in this case, let's say we choose 2 and 3. 2, 3, this point. 2 is the x coordinate, so I'm going to plug that in for x. 3 is the y coordinate, I'm going to plug that in for y. So I'm going to say 3 equals 2 times 2 plus b. Well, then I'm going to take 2 times 2, which is 4. 3 equals 4 plus b. Subtract 4 from both sides, and I'm going to find out that b should equal -1. Now, if I go back, let's go back for 1 second, and let's say, well, what if your neighbor Or let's say you decide to do it the other way. Maybe somebody you saw did use the point 2,3. But let's say instead you want to say, well, what about 7,13? What if I use that point? Again, just showing you it won't matter which point you use. Either way should work. So again, we can put 2 in for the slope because we do know that. 7,13 means 7 is the x-coordinate. 13 is the y-coordinate. So I'm going to put those numbers in where they go. 13 goes in for y. 7 goes in for 2. 2 times 7 gives me 14. So 14 plus b. If I subtract 14 from both sides to get b by itself, I also get b equals, what do you know, -1. So either way ends up working. And so as long as I just have 2 points, I have enough information to find the slope and the y-intercept of this equation. Last thing to do, I've got the slope, I've got the y-intercept. So this is y equals 2x minus 1 for an equation. I'll go through one more here, one more example, just to make sure we got the idea from that last one. Again, it says write an equation. So the first thing you need to think is, okay, I'm going to make some equation y equals mx plus b. So then what do I need to write that equation? Well, I need the slope and I need the y-intercept. Now you got to ask yourself, well, do I have either of those things in this problem? Okay, well, no, I don't. As I read the whole thing here, it says write an equation of a line that passes through these 2 points, 1, -2, and -5, 4. So no, I don't think either of those points is the y-intercept, and neither of them, and I don't have the slope there, so I'm going to have to do a little work to find both these things. Okay. Again, nice thing is, just in the previous section, we remembered how can you find the slope if I have 2 points. I can just take 5 minus -2 and -5 minus 1, so 5 minus -2, or sorry, 4 minus -2, chop chop, -5 minus 1, so there's what I've got so far. On the top, I'm going to get 6. On the bottom, I'll get -6. 6 divided by -6 gives me just -1. So there. Now at least I've got the slope. Got a slope of -1. What can I do now? Okay, we'll bring this back here. Again, this is the form of the equation we're trying to make. We're trying to put something in y equals mx plus b form, slope-intercept form. Well, now I know the slope is -1, so I could put that in for m. And then of these other things, I don't know what b is yet, but x and y, I can find those from up here. I know the line goes through those 2 points. So those ordered pairs must be ones that work in this equation. So I could use either one of these 2 points to find out what b is. Let's say, in this case, I'll take the second one. Okay, -5 is an x-coordinate, 4 is a y-coordinate, so -5 is going to be substituted in for x, and I'm going to substitute 4 all the way in for y. So 4 equals -1 times 5 plus b is what I've got now. And actually, it should be -5. Let's not make that mistake here. It should be -5. So I've got 4 equals -1 times -5 plus b. Good catch there. So what do I do next? I can multiply these two together here. -1 times -5 gives me +5. So 4 equals +5 plus b. And then if I subtract 5 from both sides, subtract 5, I get b equals -1. I know it seems like a bunch of things ended up being 1 or -1 in my examples, but just realize that isn't always going to happen. So sometimes you get 3 and 4, or 8 and 2. Could be any different numbers, but I guess some of mine just worked out and they end up being -1 or 1 a lot. So good. I've got the two things I need, the slope and the y-intercept. So what's my equation? -1x minus 1. So just as we start to go along in this chapter, we'll realize there are many different ways. There are many different types of information they might give us to make an equation, but most of the time we can get there. So we just got to be able to find those two things for sure, the slope and the y-intercept. If we can do that, we can definitely make an equation in slope-intercept form.